Well, good morning, Algebra. Before I head off to work today, I thought I'd tape a lesson on substitution. So here goes. Yesterday we talked about solving two linear equations. Like, let's put a couple of them up here. Y equals 2x and y equals 3x minus 2, let's say. So yesterday we said that you could graph that one, and there might be a certain place in space where they cross, and if there is, then that means that x and y is an x and y that makes this true and this true. So basically you solved the x and y for those two equations. Sometimes it might not cross, and sometimes it might be on top of each other, remember, but we'll talk about that in a second. Another method you could use besides graphing would be what's called substitution. You see, I don't think I've ever said this before, so let's make sure I say it now. If I just gave you the equation y equals 2x, you have two unknowns. The problem with having two unknowns in one equation is you can't solve it, because when you have, well, let's just say we have one unknown, then you can solve it. When you have two unknowns, you need two equations to solve it. If you had three unknowns, of course you'd need three equations, and so on and so on. Well, lucky for us, we do have two equations now. We've got y equals 2x and y equals 3x minus 2. And in fact, if you think about it for a second, we can make this equation have just one unknown by a method called substitution. What this equation is saying, y equals 2x, it means everywhere where I see y, I could substitute 2x. It's exactly the same thing. So that's what I'm going to do. I'm going to put 2x in for y right here. And the great value in doing that is it simplifies our equation down to just one unknown. So I'm going to put that in for that. 2x equals 3x minus 2. Now if you look at it, there's just one unknown that we have. And since we have one equation, we can solve that. So I'm going to get the x's on one side. So bring this over here and subtract it. So I'll get the opposite of x equals -2. And when I divide both sides by -1, I get x equals 2. Well, now I'm halfway home. Originally I wanted an x and a y. Well, now I have an x. And once I have this x, I can simply go back to either one and substitute it in there. But it's good. Do you see it's going to be an easier form if I go back to the original substitution one. Now, if x is 2, then 2 times 2, y is going to be 4. Okay? So remember, what I'm really talking about is I'm talking about a point in space. So I'm going to express that as an ordered pair. 2, 4 is that point that if I graphed these two, it would cross at that point. And it's also the x and y that make both these equations work out. And you could plug that in and try it for yourself. Okay? In fact, I encourage you to pause the tape right now, check it, and see if it really works. Okay? While you were doing that, I erased. So for substitution, here's your steps that you want to do. You're going to have two linear equations that they'll give you. You solve one in terms of x or y. In other words, you have x equals something or y equals something. And then you substitute that into the other equation, if you had it in terms of x, you substitute it in for x. If you had it in terms of y, you substitute it in for y. To get an equation with just one variable. And then you're going to solve it. And then lastly, you're going to put it back in the original and solve for the other variable. Okay? That's all there is to substitution. Let me show you a couple, maybe what you call special cases. Let's say we had x equals 2y and 2x equals 4y. Oops, x equals 2y. Now you might be able to see right away that those are essentially the same problem. But let's just try this anyway. X equals 2y, so instead of x, I'm going to have 2y. So I'm going to substitute that in right there. 2 times x is going to give me 4y equals 4y. And when I get the y's on both sides, I'm going to end up with 0 equaling 0. Of course 0 equals 0. Okay? That's not a big brain buster. But what that's telling you is every single y that you stick in that side, it's going to be the same on that side. And so this is a case where you're going to have two lines that were right on top of each other. And so every x and y in this one is going to make this one true. So we're not going to get a specific x and a y. I mean, we're not going to get one specific point. This is a case where all the solutions match. Every x and y are going to be the same for both of them. What if I gave you another one that's like y equals 3x and y equals 3x plus 1. Now you might be able to think to yourself, what's happening here? We have the same slope in both of them, and we have a different y-intercept. So one of these is going through the 0 point, and one of these is going through the 1 point, but they're going to be parallel to each other. So you can probably guess that there's going to be no solutions that make both of them true. Let's try solving it real quick. So instead of y, I can have 3x, so I'll put 3x there. 3x equals 3x plus 1. Get the x's on both sides, and I end up with 0 equaling 1. Well, that's not going to make any sense ever. 0 will never equal 1. So in other words, there are no x and y's that I could find that are going to work for both of them. Okay? So those are two special cases. But in general, substitution just relies on a little trick. So instead of having instead of having two unknowns that you have, you just rearrange things so you get one unknown and solve for that unknown, and then you go back and you find the second one. All right? Hope that made sense.